and kick it out in this garage.
Okay. Hey, let me make one slight change here. And okay, I decided you needed to see me in full screen. And Dick, am I full screen?
No.
And what do you see on the screen?
You're muted, Dick, but I see 3 squares.
Kind of locked up, Al.
Yeah, you're frozen.
Yeah, you're locked up, Al. Try again.
Well, I think he went to photo, but he hasn't shared his screen yet. There we
There
go.
we go.
Okay,
now
there
we
see you full screen and ready to roll.
In all my radiant beauty. Okay.
Yes.
Well, good afternoon. Sorry about that hiccup in the beginning there, but that obviously does happen. What I'm going to do today is not probably going to take even a half an hour, but we're going to look at an engine. I'm going to ask you to unmute and maybe come up with some answers. And I'm not looking for long explanations, just some short answers to some basic questions, the kind of questions that you might want to ask students when they come and they're working on a particular automobile. Okay, the automobile that we're working on today is a 2017 Chevrolet Equinox, then L. L is in love. And I've done a few things to start with here. Let me turn on that camera. Okay, now you should be seeing the engine. Are you?
Yes.
Good, thank you. You guys got to stay awake here. You know, don't fall asleep.
I keep muting myself, Al. I'm going to stay unmuted so I can answer you.
Stay unmuted. That's fine. Okay, now what I've done is not a whole bunch, but I took the cover off. And to get the cover off, I also took off the airbox. Okay, and I'm going to have to put the airbox back on because it doesn't like running without mass airflow. And the mass airflow is obviously upstream. But the thing to ask students is to say, okay, what kind of a system do you see here? And you obviously come up with a couple different questions or answers. What do we have here? What do you see? Crickets. Come on, what do you see? Anybody?
Coil on plug.
Unplug?
Coil on plug, right? And how many do we have? We have 1, 2, 3, 4. Well, it's a 2.4 liter 4-cylinder, so it's truly coil on plug. Now, the next thing that we want to do is we want to identify things. So I've gone and I've taken, and I realize you can't read this, but anyway, I printed some specs. And what we have here is we have 4 wires, okay? And I think you can see that, okay? 4 wires. And I'm going to be working on coil number 4. So what I printed was that. The A connection, which is all the way on my right-hand side, is ground, and it's a black wire. C connection is ignition control 4, and you can see I have a probe in that. That would be this wire right here on that coil, okay? And then the last one, which is a pinkish red with a black stripe, pink with a black stripe, is power to each one of the 4 coils. So each one of the coils has got a different control color. I got purple there, and I can't really see there. Here I have brown. No, sorry, I have green and brown, and here I have green. So that identifies. Now, with that in mind, what kind of information can we get? First question, ask students, okay? You have power, you have ground, and according to what the manual says, you have ignition control 4 on the 3rd terminal. So what can we get here? For instance, can we get secondary voltage? Yes or no?
Probably no.
No is the right answer. It's not going to be available. We're going to have to use a paddle probe on this. Can we get primary current?
Yes.
Yes, but it won't be accurate.
Okay, we can get primary current because that's that pink wire with a black stripe. Can we get a primary voltage trace? Now, this is a little bit of that was not a strange question, but a question I put to you, and with the idea that you might have to think about this, or the student would have to think about this, because yesterday we talked about where is the module? Is the module inside of the PCM? Is it external to the PCM, or is it internal to the coil? In this particular case, because again, you have ground, you have power, and you have ignition control, which on a wiring diagram comes from the PCM, it means that there's no primary. The ignition module is inside, okay? Now, I'm gonna put the air box back on just kind of temporarily because again, it doesn't want to run without it. And we'll still be able to see
Only pays 2/10.
Pardon?
Nothing.
Now, it may get a little noisy. Okay, engine's running right now, and I'm going to switch over to a Picoscope.
You haven't connected anything to the tap point, right?
Good point, Dick. Let me go backwards here. Thank you. Okay. Good comment, and I appreciate that. I've taken all three grounds, excuse me, and connected them together. The reason I say three is, this is my current probe, this is my A channel, and this is my B channel, and there's just a ground clip, and I'm just gonna go clip it to a bolt. Nice clean bolt on the motor. Okay, I'm gonna take channel A, and I'm gonna connect channel A to control. And now we'll go. Now, a couple of things here. First of all, we got quite a bit of noise, but you see the square wave coming across. So the first thing that we want to do is we want to trigger. So I'm going to go over here and I'm going to put on auto trigger. And then I'm going to take my trigger and I'm going to raise it up. Okay, I'm going to lower this down. And normally you want trigger somewhere around 50%. Okay, we're making headway. The next thing I want to do is, if you're following this, I want to fill the screen a little more. So I'm going to go up here where it's at 5 milliseconds, and I'm going to go down to 1 millisecond. Okay, that gives me a much better pattern. The last thing I want to do is I want to turn on some filtration. You're going to find when you're dealing with an engine, the engine is running, the engine is producing radio frequency interference all over the place. You need to put some low pass filtering in. So I'm going to go over here where it says activate filtering, and you'll notice that right away it kind of cleaned it up a little bit, but it's not square. And the reason it's not square is I need to give it a little more filtration. Now, that's probably about as good as it's going to get. Now, let's freeze it by hitting the space bar. And is the noise from the motor objectionable?
No, not at all.
Okay, all right. Well, I'll keep going.
Cannot hear it at all.
Okay. I'm using headphones that are supposed to cut out some of this. Now, one of the things that we say we want to know is how long is primary current actually going to be on? Or in this particular case, how long is the signal going to be on? Okay? Can you see the number over here on the right-hand side? I'm sorry I can't make it any bigger, but it's 3.093. Yesterday I gave you a spec. said it must be greater or should normally be greater than what?
8/10.
0.8.
Pardon?
8/10.
No, that's
Oh, no,
burn
no,
time.
no. Yeah, I'm sorry.
How long would primary current remain on? About 2.5 milliseconds, greater than 2.5 milliseconds.
Yep.
Okay? All right. So now we're going to add something to this. And to add it, I'm going to go back to the camera. Okay? And I'm going to come across with a current probe.
You still okay, Al?
Yeah, I don't know why I didn't see that live, but let's try again. Turn the camera on one more time. All right, not sure what's going on, but I'm going to forget it for right now. Now, I have a current probe, and I'll see if I can get a picture of it in a little while, but I put that current probe on, and it's on channel B. So the first thing I want to do is go up to it, and I'm going to turn it on, and I'll put it on auto. Okay, now, let's spread these out, and let's put them in a little different order. So what does this show? Well, it shows that we have current flowing as soon as we get the signal. Here's the signal from the PCM, and that's when current begins right here. Current ramps up. When current gets to its, as far as it can go, we don't know if it would go further, but we turn primary current off with the signal from the PCM. And we do that call it 3 milliseconds later. Now, yesterday I talked about 2-function, 3-function, and 4-function modules. Based on this diagram, what do we have here?
Two.
We have a 2.
Function.
We have primary on, we have primary off. If the top here was flat top, it would make it current limit, and we would have maybe 3. Okay? Make sense so far? Are you with me?
Yes.
Okay. I've gone back live again. I'm going to make one more attempt. Now my Droid camera has officially given up the ghost. So let me take a minute here and see if I can get the camera back. No, can't connect for some reason. Not sure what it is. Okay, no more camera. Sorry, guys.
It would
Anyway.
just show us your current clamp connected around the wire, would it not?
Yes. Now I'm going to disconnect. I've disconnected my signal. I've lost my probe. This is crazy. Well, this is the live by technology, die by technology, guys. Oh, here it is. Okay. Okay, I've got a paddle probe, and I'm going to put the paddle probe over the top of the coil. But first, I'm going to turn trigger off. I need to see if I'm actually getting a pattern.
Is it just me or are we not seeing Al's Pico screen?
No, I see the screen and there's a pattern floating by every once in a while.
Oh yeah, I got it now. Sorry.
As we all know, this probably worked great in practice as we were getting set up, right?
Worked perfectly in practice. Which we knew.
Still interesting to watch the pulses happen when whatever you're doing, Al. You know, when the pulses happen, you can see the voltage spike.
Unfortunately, this is another one of those Murphy Law things.
Yeah, well,
Exactly.
you know, I'm not done trying yet, guys.
Yeah, no, that's good.
We're with you, Al. Hang in there.
Not like we haven't all been there.
Yes, for sure.
10 minutes ago, actually.
Yeah, from the start of that motion picture.
What I'm doing now, by the way, is I'm just kind of trial and erroring my voltage signal. And I'm sorry, that's the wrong one. My voltage signal, I'm going to go up to 200. And we're going to put this. Okay, let me turn the car off here. The last thing, the important thing here is the spark itself. The spark itself. This is the beginning of it right here, and this is the end of it. So what's the time here? Well, again, we use our cursors and we say, okay, somewhere over here. And these are all approximate. And somewhere over here. Actually, I'm in the wrong place. Here's the end of the spark. Okay, so this is actually the spark right here. Now, I'm overranged, but I don't care. Because why am I looking at this? The reason that I look at this in the first place, and the only reason I look at it is, I want to be sure that I have a secondary spark, which lasts, and what's the spec?
8/10 or more.
Yeah, 8/10 or more. And this one is, because this one's sitting at 1.026 milliseconds.
That's
So-
burn time, correct?
That's burn time. Absolutely, that's burn time. That's how long did the spark actually last? And you know, it's usually a really nice clean signal. And I have a couple. I got a choice here. I want to try one other thing to see if I get a little better signal. First off, I have a lot of filtering on. That's it right there. Okay. I'm going to start again. And the lawnmowers are outside. Now, if you're listening to them, not much I can do about it. Okay. Let's go live. Take our cursors out of the way. That's a little better. Okay. And again, here's where the spark began. That's where the firing line would be. I'm still over range, by the way. And then it ends somewhere here. It's a little difficult to find the exact spot where it ends. I mean, I guess in theory, it could be all the way out here, but I kind of doubt it. It's going to be somewhere probably right there is where it ends. And again, that's over 1 millisecond. So,
What would the pattern look like if the coil was shorted?
I had a picture of that yesterday, and I didn't load the.
Okay,
I
that's
didn't
fine.
load it today, but
I was just,
what it is you have a current that when the current ramps, it ramps up and then it flat tops. But rather than ramping, it goes straight up. A shorted
okay, yep,
coil
I
is
remember.
straight up, and it gets up. And these coils here, because they don't have current limit, you know, usually what happens is you wind up burning the coil out totally. So when
Yeah.
when the resistance gets lower and lower and lower, the current keeps getting greater and greater and greater and greater, and eventually it gets to the point where it burns the control circuit out in the coil.
Now, that last pattern you obtained was with the COP paddle, correct?
Yes, with the paddle.
Right.
Okay. So what I used when my camera decided to take the rest of the day off was I used a current probe. I used a Pico current probe, and I used it on low current, which was 100 millivolts equal 1 amp. Excuse me. And then I used the coil adapter here, which is usually called a paddle probe. And this was the thing I couldn't find because it had fallen. I wanted it to be nice and easy to get to, so I put it on the motor, and then the vibration of the motor had slipped down.
Yep.
Okay, I'm going to, I am going to unshare. Did it unshare?
Yes.
Yes.
I'm done. Who's got questions?
Well, one of the other things I noticed was that the signal from the ECM to the coil pack was a 5-volt signal. So the
Yes.
triggering was doing 0 to 5,
Yeah, 0 to 50.
which
And I'm guessing, but I think you could confirm, Rick, that is simply a low current control device to keep the driver, you know, down to the point where it's not so high amperage sensitive.
yeah. And I mean, it's important to point out, you know, to someone that might have a lot of familiarity with ignition systems that you're going to find a 5-volt signal. And if you went back to the old coil packs where the signal coming from the ECM was, for all of them, was a 5-volt signal, right?
Mm-hmm.
Should somebody wake Russ up, or do we just let him sleep?
No, he's there. He screenshotted his last time he fell asleep.
Oh, I see. Oh, hi,
He's
Russ.
being, cute.
He's just being a smart ass, you know. Okay.
Yes.
Any questions? You know, I let me go back and just make a couple of mentions here, and that is, I think you've got to get the students to the point where they look at a system, perhaps look at a wiring, not perhaps, look at a wiring diagram, and look at the actual pinouts on the coil, and then figure out what they have. Okay, this is a coil on plug. I mean, you can easily prove that with one 13 millimeter bolt that takes out, and the whole system would come out. Okay, you can show it to them, or they can do it themselves. They have to recognize what they can get and what they can't get. And your choices are primary voltage, primary current, control voltage, not control current, but control voltage, and secondary voltage. So you really only have 4 choices. Now, what do you really need? It would be nice to see that, yes, I have a spark. Well, your paddle probe will show you have a spark. Secondly, I can get on this one, I can get primary current, and I can get control voltage. I can't get secondary. In most cars nowadays, you can't get secondary. There is Pico sells a probe that clamps over this coil. Okay, it's about 20 bucks. And the way I look at it is that's $20 that I really don't need to spend. And I might as well, not spend it because the paddle probe does it for me. So with that, Jimmy, maybe you should turn it off.
I'm happy to stop the recording.